The drug cortisone has the formula this is a drug. In addition to those chiral centers marked by asterisks, how many other chiral centers are present in cortisone molecule? So this drug has 3 chiral center. This is shown asterisks. Now how many other chiral center has? Answer will be 3. D. Which are others? This is 1 and 2, 3. So 3 other chiral center has. Answer will be 3. 3 given and 3 others. 1, 2, 3. Chiral center means a carbon having 4 different groups. Compound X reacts with acidified potassium dichromate to form compound Y. The infrared spectrum of compound Y is given. So you see compound Y is a carboxylic acid because CO group present, carbon oxygen double bond peak is present, and oxygen hydrogen bond present, hydroxyl group present. This is broad peak due to formation of hydrogen bond. So Y is a carboxylic acid. Now X will be primary alcohol because primary alcohol oxidized to form carboxylic acid Y. You are asking what is the identity of compound X? So answer will be A. X will be propanol because propanol is a primary alcohol. Primary alcohol oxidized to carboxylic acid, propanoic acid, and propanoic acid has CO peak 1670 to 1740. This is the peak, and oxygen hydrogen hydroxyl group 3200 to 3600. Citral is found in lemongrass oil. It can react to give compound W. Citral reacts with excess hydrogen in presence of nickel catalyst. It will form B will be alkane, and hot concentrated acidified manganate 7 under reflux, that aldehyde group oxidized to carboxylic acid. So which compound WB? If citral reacts with hydrogen, so this alkene will convert to alkane. So this will be alkane. This double bond break down to form alkane. And if then aldehyde group oxidize acidified manganate 7 will convert to carboxyl group, carboxylic acid. So B is the right answer. A is wrong. Why? Aldehyde, same aldehyde, but aldehyde oxidized to carboxylic acid. B is the right answer. Dimethyl propanitrile reacts to form alcohol Y via the reaction scheme below. So cyanide compound, nitrile compound goes to acid hydrolysis, it will convert to carboxylic acid X. Then if carboxylic acid is reduced to lithium aluminum hydride, it will form primary alcohol. So what will be the answer? This answer will be C. Molecule X will be dimethyl propanoic acid and Y will be primary alcohol. Why? You see, this is the dimethyl propanitrile. So CN group will convert to COOH group, acid hydrolysis. So dimethyl propanitrile will convert to dimethyl propanoic acid by the aqueous acid hydrolysis. Then carboxylic acid, I mean dimethyl propanoic acid, if you reduce lithium aluminum hydride, it will form primary alcohol. So Y will be primary alcohol, and C is the correct answer, dimethyl propanoic acid, and it is the primary alcohol. Lactide is an intermediate in the manufacture of synthetic fiber. This is the lactide. You are asking which compound on heating with acid catalyst can produce lactide. So lactide is an ester. If you acid hydrolysis ester, you will get carboxylic acid and alcohol. So here this will break down here. This O, one hydrogen will be added, and this is carbon-oxygen double bond, and hydroxide group will be added. Two oxygen, with oxygen hydrogen will be added, and carbon-oxygen double bond, hydroxide group will be added. So this name will be 1, 2, 3 propanoic acid. Number 2 carbon contains hydroxy group, so 2 hydroxy propanoic acid. Answer will be C, 2 hydroxy propanoic acid. A sample of magnesium nitrate is heated. The pH of the solution in the trough is measured. The gas collected is tested with a glowing splint. So what are the result? This answer will be B, pH will be 2 and relights. So why B answer? You know, magnesium nitrate break down to form magnesium oxide, brown fumes of nitrogen dioxide plus oxygen, and nitrogen dioxide dissolve in water to form nitric acid. So pH lower 2, and as oxygen is produced, so you know oxygen relights a glowing splint. So B is the right answer. Any group 2 nitrate, here magnesium nitrate, thermally decomposed to produce magnesium oxide, brown fumes of nitrogen dioxide plus oxygen. Nitrogen dioxide dissolve in water to produce nitric acid, so pH falls to 2, strong acid, and as oxygen is produced, so oxygen relights a glowing splint. X and Y are reagents required to convert 1-bromopropane into butanoic acid. 1-bromobutane is converted to butanoic acid. X and Y are two reagents. So what are the correct identities of reagent X and Y? That means X and Y are what reagents? So you see, this is 1-bromopropane, this is haloalkane to cyanoalkane or alkane nitrile. This is reagent is X will be potassium cyanide dissolved in alcohol, ethanol, potassium cyanide dissolved in ethanol, and Y nitrile compound to carboxylic acid, acid hydrolysis. So if CN group is acid hydrolyzed, it converted to COOH group, carboxyl group. So butane nitrile goes to butanoic acid, reagent is aqueous hydrochloric acid. What are the only structures formed when butane 2-ol is heated with concentrated sulfuric acid? And you know, if butanol alcohol is reacted with concentrated sulfuric acid, dehydration reaction occur, alkene will be formed. So butanol will form 1 butene and it can form 2 butene, and 2 butene has two isomers. This is cis-butene and this is trans-butene. So if butanol is heated with concentrated sulfuric acid, dehydration reaction occurs and three possible products. One is 1 butene, other is 2 butene, but 2 butene has two isomers. One is cis-butene, other is trans-butene. So there are three products. The diagram shows the structure of two star X and Y that are formed in ripening apples. Star X and star Y. X and Y are two star. So you are asking which carboxylic acid are formed when these stars are hydrolyzed by sulfuric acid. And you know, if star is hydrolyzed with aqueous sulfuric acid, you will get carboxylic acid and alcohol. So this is functional group star. If it hydrolyzed, this will break down here. So CH3CO OH group will be added. So CH3 COOH, one will be ethanoic acid, and here will be breakdown here. So one OH group will be added. So this name will be 1, 1, 2, 3, 4. 2-methyl butanoic acid. So other product will be star Y gives this carboxylic acid and star this X. Ethanol can be used to make propane nitrile in two steps. Ethanol goes to bromoethane, then propane nitrile. What types of reaction are X and Y? Alcohol to haloalkane, this is nucleophilic substitution. So answer is C, nucleophilic substitution. And Y, bromine nucleophile is substituted by cyanide nucleophile. This also nucleophilic substitution. So C is the right answer, because hydroxide, this nucleophile is substituted by bromine nucleophile, and Y reaction, bromine nucleophile is replaced by cyanide nucleophile. So X and Y both will be nucleophilic substitution. Answer is the C is the right answer. The diagram shows structural formula of a hydrocarbon molecule Q. How many of the carbon atoms in molecule Q are sp2 hybridized? So this answer will be 4. There are 4 carbon are sp2 hybridized. Which carbon? This carbon 1, because this carbon is attached to single bond and one double bond, and this 2, this 3, 4. These 4 carbon are sp2 hybridized because the carbon which are attached to single bond and one double bond, that carbon will be sp2 hybridized. So 1, 2, 3, 4. These 4 carbon are sp2 hybridized. This carbon-carbon triple bond, this is not sp2 hybridized, this is sp hybridized, and this carbon is not sp2 hybridized because it attached to double bond. The diagram shows a section of an addition polymer. The polymer is made using 2 different monomers. This polymer is made by using two different monomers. So you are asking what are the names of the two monomers needed to make this polymer. That means what are the two monomers that can make this polymer. So this answer will be A 1,2-dichloropropene and 2-chlorobutene. So how you will get answer? This, you see this one monomer and this another monomer. If you close this bond and double bond give here, so you will get this molecule. Left carbon contains chlorine and CH3, right carbon contains hydrogen and chlorine. So this 1, 2, 3 propene, 2,3-dichloropropene, and second monomer, if you give double bond here, left carbon contains CH3 and Cl, CH3 and Cl, right carbon contains hydrogen and CH3. So this is the 1, 2, 3, 2-chlorobutene. 1, 2, 3, 4, 2-chlorobutene.